All right, so now we're going to practice with the sine and cosine curve. So, this lesson is really just using what we did last lesson, which is learning how to. Now we're just going to really hone those skills and keep practicing here. So let's take a look. This first example, we are going to graph on the interval from negative 2 pi to 2 pi. So this time our x-axis, instead of being from 0 to, whatever our period is, this time it's going to be from negative 2 pi to 2 pi. So I'm going to have you guys do this on your own. I'd like you, per usual, start by identifying all of your characteristics given the equation, and then try to graph this. Okay, so go ahead, put me on pause, and let's see how you do. All right, so let's check this information here. So you should have a vertical shift of 0. Your amplitude is positive 1/4. The period is 4 pi. The horizontal shift, or the starting x value, is at 0. And the intervals will be pi. So I started by just drawing the setup of my graph, right? I think this is always like a good place to start and kind of check in. My amplitude goes to positive 1/4 and negative 1/4. Since there's no vertical shift, our ground, why can't I ever remember that term? But our, middle ground is always, which by the way, that's not an official term. I just made it up. Middle ground's at 0. Our intervals go by pi, so pi, 2 pi. Remember we said we want to go from negative 2 pi to 2 pi. And because our period is 4 pi, since we're only graphing on this interval, we're not actually going to show a full period in terms of like 0 to the full period of 4 pi. But we will show a full period from negative 2 pi to 2 pi because that is representing 4 pi. Okay? Now here's the part that becomes a little bit tricky is how do I know where to graph my points? Remember our starting x value is at 0, right? And since it's a sine graph, we know that we start at 0, 0, right? And because it's negative 1/4, instead of going up next, we're actually going to go down. And then from there, it's just kind of following the shape of the curve, right? And then I can kind of connect my points here. Awesome. Let's look at this next one. This time we're going to graph two periods of y equals negative 2 cosine of pi x over 2. So same thing here, identify the information, and I really challenge you guys, please try to graph the entire thing on your own. Okay, that's the only way you're going to get better and actually understand this is if you try it on your own first. Okay? So, go ahead, put me on pause. If at first you don't succeed, there's always an eraser. All right, so just checking these characteristics here. So it's a vertical shift of 0. Nothing's added or subtracted. Amplitude is 2. Period is 4. Horizontal shift is 0. So our starting x is at 0. And then the intervals will be 1. So again, I think it's helpful to see this first, right? Amplitude 2 to negative 2. Intervals are 1. So I know I'm going to have a 1 period between 0 and 4. And then my second period from 4 to 8. But now I got to figure out what about this curve here. So let's think about cosine. Well, cosine usually starts at 1 or, whatever our amplitude goes up to. But since this is negative, I'm actually going to start at negative 2. And from there, I'm just following the shape of the curve that we're familiar with. And there's my two periods. Getting better at this? Good. All right, next one. Graph two periods of the following equation. So same thing. Let's have you guys identify this information first, and let's put this on a graph. And notice here that there is a vertical shift, so make sure that you recenter based off of this shift of negative 1. All right, go ahead, put me on pause. All right, so let's take a look here. So I have a vertical shift of negative 1, amplitude is 3, the period is pi over 2, The horizontal shift is pi over 4. So we're starting at pi over 4 instead of 0. And then the intervals are pi over 8. So looking at our setup, don't forget what this dashed line means. You don't have to have that graph, but I think it's helpful. I know that this vertical shift at -1, so I'm going to go, because of the amplitude, 3 above and 3 below. My starting x value is at pi over 4, and each interval is going to be pi eighths away. So back to the drawing board here. If I'm starting at pi over 4 and it's a cosine graph and it's positive, I am going to start up here at 2, and then, oops, that last one was bad. Ignore that. Pi over, or sorry, at 2, go to my home ground, which is at -1. Keep going. That keeps messing me up, that x-axis. Good. Sweet. All right, and there's my graph. All right, next example. This one's slightly different and a little bit different of thinking, but honestly, it's ultimately the same thing. It says, write the following graph as both a sine and cosine function. Whoa, both at the same time. That's crazy. Okay, but you can do this. I have faith in you, have faith in yourself. So what I want you guys to do first is understand that this process is the same. That's really my big hint to you. Process is the same as in first identify all of your characteristics. Figure out what's the vertical shift, what's the period, amplitude, so on, so on, so on. Then just, use the formulas. You guys can find the cosine and sine function, okay? One other hint that I'll give to you guys, and I'll kind of draw it out for myself, and then I would recommend that you draw it for yourself, is that understand that there is a vertical shift here, and I won't say any more, because there's too many hints out there for you. Okay, so go ahead, first identify the things, and then try, T-R-Y, try, okay? Go ahead, put me on pause. Okay, so let's check our answers here. So just visually looking at our graph, we can see that the vertical shift is -1, the amplitude is 2, and the period is pi. So how do I get that the period's pi? Well, I know, that I would do 2 pi over b, the number that's multiplied in front of my x minus c. So what would b have to be in order for the period to be pi? Well, it would have to be 2. So the sine is fairly easy to figure out. And I say that because of looking at where my graph starts. It starts at -1, which is where the vertical shift is, right? So understanding that, I have y equals 2 times the sine of 2x minus 1. No vertical shifts. Okay? Now, this one's a little bit harder because there is this vertical shift. And there's a couple of ways to think about this. One of them is, think about, if I look back at this graph, what the heck? If I wanted this to start here, that's a vertical shift of pi over 4, or sorry, horizontal shift at pi over 4, right? So that's where that minus pi over 4 comes from. And you can also think of it in this way as well. Yeah, so a couple ways to think about that there, but I would accept this answer. All right, one final and challenging example for you guys. There are many correct answers to this problem. It's basically asking for the same thing. Write this as both a sine and cosine function. All right, so go ahead, put me on pause and try it out. All right, so when starting this problem, I started by checking out if there was, which there is in this case, a vertical shift. And it is, there's a vertical shift of 1. The next thing I would really draw your eyes to would be, our points of interest that we would graph. Okay, because that's going to help you identify, any horizontal shifts. Okay, so let's see what I had written down here. I said vertical shift of 1, amplitude is 3. Hopefully you guys can figure that out. And the period here is 2. Okay, so now it's a matter of figuring out what is our starting x value. So like I said, there are many correct answers here, but for the sine graph, I said that my starting x value would be at 3/4, which is right here, which makes sense, right? That could definitely work. And we could come up with other examples as well. For my starting x value for the cosine graph, that would be at -3/4, which could be here, which I could have also started here if I wanted to, but I chose here. So starting at -3/4 and then completing a full period would, is graphed on here, which the period, like we said, was 2. So that's just one of many options for answers. All right, great job.